Hi everybody, we're back again for another exciting night of scientific notation. Today, hold on if I can get this to work. There we go. Today we're going to be looking at how scientific notation can help us write numbers that are way too large to write out in standard form. Did you ever think of things like winning the lottery and how much money that is, how many people there are in the entire world, what our national debt is? Those numbers are enormous, and sometimes when they're written, or because they are so big, we like to write them in a smaller form to make it easier to understand. So that's what we're going to learn today. First thing we're going to do is we're going to be converting numbers from standard form to scientific notation. Standard form means just a regular old number, and we're going to be placing that into scientific notation, which you learned is a factor multiplied by an exponent with a base of 10. So let's go back. Let's remember. A number is expressed in scientific notation when it is written as the product of a factor and a power of 10. Don't forget what the word product means. Product means multiplication. It's an answer when we multiply. And I'm just going to write that down here. Excuse my handwriting, though, it's terrible. Answer when we multiply. Okay. So if you want to go ahead and write that, you can as well, just to remember. You also have to remember this, that factor must be greater than or equal to 1 and less than 10. So don't forget that first factor has to be greater than 1 or equal to 1, but less than 10. Don't forget that. Ooh, look at, there's Mr. Moneybags hanging out. Okay, so now this is what we're going to do. Let me erase this so you can actually see what this written there. Okay, it says the largest Powerball jackpot in history, and this is true, was $590 million. That sounds pretty good right now. I might quit my job. I would never quit my job. How could we convert these winnings to scientific notation? Let's take a look. Here's our jackpot. We have the number written in standard form, $590 million. When we convert standard form to scientific notation, these are the steps we're going to follow. So let's look at step 1. Write the first factor as a number between 1 and less than 10. Which way would you need to move the decimal? Well, let's look at the number again. We have our $590 million. Where is the decimal to start? It's right there. It's at the end of the number. So what we're going to do now is we're going to have to move that decimal point to make sure our first factor is between 1 and less than 10. So here's our original decimal point. Ooh, look at our red decimal point. Our red decimal point, notice, is between the 5 and the 9. Think about that number as a decimal. If we look at the number 5.9 as a decimal, isn't that between 1 and less than 10? Hopefully you're saying yes and you're agreeing with me right now because it is. So that becomes our first factor. And here's our new decimal point. So what we're going to be doing is moving our decimal from the original to the new, which is moving to the left. So our first factor will be 5.9. Now we're going to take a look at what that will look like when we write the actual exponent after it. We have our first factor written here as 5.9. We have our original number with our 2 decimal points. Now remember, whenever we're rewriting numbers, we can never rewrite them with 2 decimal points. But in this situation, I have to show you that, so you're going to see how that decimal point moves. So now we're going to step 2. You're going to find the power of 10. And by doing this, you're going to count the number of places from the original decimal point to its new placement. So, okay, nothing's popping up. There it is. Okay, so here's our original number. This is what we're doing now. We are counting the number of places from the original to the new decimal point. So there's 1, 2, 3, 4. Oh, wait, I think I counted wrong. There's 1, 2, 3, 4. I was right. 5, 6, 7, and, oh, wait, it's not showing up. There it is, 8. I knew it would come. Okay, so now we've moved that decimal point 8 places to the left. So that becomes our power of 10 exponent. So our second factor will be 10 to the 8th power. Bam. So our first factor we know is 5.9, and we know our exponent is going to be 10 to the 8th power. So now what we have to do is write those 2 factors as a product. And remember, once again, a product is an answer when we multiply. So once we rewrite it, it looks like 5.9 times 10 to the 8th power. Now, if you're someone that has a handy-dandy calculator with you, you can go ahead and try that on your calculator and see if you get back to the original number. I guarantee you do. So there it is. 590 million is really 5.9 times 10 to the 8th power. Now it's your turn. You're actually going to convert the following from standard form to scientific notation. So here are three numbers in standard form. We have 224,000, 305,200,000, and 667,020,000. Holy moly, I can't even read it. It's so big. Thank God we have scientific notation. All right, so go ahead and pause the video, try to write those in scientific notation, and then turn it back on. Hopefully you try those on your own and you are back with me. So let's check our answers now. Now remember, right now if I look at that 224,000, my original decimal point is here. Oh gee, it's not working. Oh gee, things are popping up. Sorry. Okay, my original decimal point is here, and I need to make sure that first factor is between 1 and less than 10. So where would I have to move my decimal point to make sure that that's where it's located? Well, let's count. I've got 1, 2, 3, 4, 5. Ooh, let's check our answer and see if I get it correct. 2.24 times 10 to the 5th. Woo, I got it right. All right, ready to try the next one? Our original decimal point is here. Oh, let me write. Oh, gee, I keep pushing too hard or something. Sorry. Now let's go ahead and move it so that number is between 1 and less than 10. 1, 2, 3, 4, 5, 6, 7, 8. Bam. 3.052 is definitely between 1 and less than 10. Let's check our answer. Here it goes. Oh, I got 3.052 times 10 to the 8th. Yay, I got it right. All right, let's try the last one. And I hope you got it right too. Okay, let's look at the last one. Here's our original point. Now we're going to move it so this number is between 1 and less than 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm nervous. I hope I get this right. So 7.66702 is between 1 and less than 10. Let's check our answer. There it is. 7.66702 times 10 to the 9th. I hope you got them right. All right. So our focus question. This is what I need you to answer and bring with you to class tomorrow. How do you convert large numbers in standard form into scientific notation? Kind of give me a roundabout way. You don't have to write out the steps, but do as best as you can in summarizing those. We'll see you in class tomorrow, and hopefully you have this done when you walk in the door. Actually, you will have it done. And just remember, you love doing your math homework. You do. Okay, talk to you later. See you tomorrow. Bye-bye.